We are now at 11 a.m. Pacific, 2 o'clock Eastern. So good morning, good afternoon, depending on where you're calling in from. If you're tuning in, this is the Retrotec Ask Us Anything webinar. So we've got a lot of brain power on today, a decent list of questions that you guys have sent in, and we'll be taking more questions as we get going. First thing to mention, go ahead and get familiar with the question and answer box. So as you have questions that pop up, utilize that. Don't raise a hand or try not to use the chat. We'll be checking both, but try to put all your questions in the Q&A box, and we'll be policing that throughout the discussion. So I'm going to go ahead and introduce everyone that's on here today. If you're new to our webinars, my name is Sam Myers. I'm one of our trainers and our in-house building science consultant. We also have Lee Canegaly. He's tech support. So if you've ever called Retrotec with a technical issue or scheduled a calibration or something like that, chances are you've spoken to Lee before. So Lee, thanks for joining us today. He's usually on the background on some of our webinars that we've also done too. Also with us is Darren Kennedy. Darren's one of our co-CEOs. And basically, he's in charge of all the business-related aspects of Retrotec. We operate all over the world, and there's a lot of resellers that we deal with, and a lot of different policies, a lot of different test standards, a lot going on. So Darren always has a lot to keep up with. And before his days at Retrotec, Darren used to work for Microsoft. So Darren, thanks for being on with us.
Thanks.
And of course, our other co-CEO, Ben Walker. Ben is in charge of all things technical, so he oversees our engineering team, our software teams, our development teams, and he has been with Retrotec for quite a while, since the mid-90s, and so chances are, if you use some of our tools, Ben's had his hand in that design, so he'll be definitely getting into the weeds on some of our technical questions today, so thanks, Ben, for coming on.
Yeah, you bet.
And of course, last but not least, we were able to sneak Colin Genge in here. Colin is the founder of Retrotec and the former owner, and so he'll be adding his input into some of these questions as well. So Colin, thanks for being with us. Cool. So we'll go ahead and get started here. So we do have a list of questions that we're going to go down. And probably the most common question that I've been getting recently, as I've been talking with folks on the phone and over email and things like that, is basically just, how are we doing? We're still in the middle of this COVID-19 pandemic, and it's still a weird thing that everybody's still getting used to. Everybody's been affected by it in some shape or form. So Darren, why don't you give us an update?
Okay. Well, obviously, at the beginning of it, when we started through, Washington State, which is where we're located, ended up having a stay-at-home order. Ben and I had discussed it prior to that, though, and actually 1 week prior to the official stay-at-home order, we actually did shut the company down and move as many people as possible to working from home. Once the stay-at-home order came into effect, we were still able to continue as an essential service, and we had just minimum staff working to produce product and get it shipped out the door. And since then, we are now probably about, I would say, close to 50% staffed in the office, and the people that can work from home are still working from home a fair amount. It hasn't affected any shipping. We've been able to continue ship all the product we need. Our suppliers were still able to get us the stuff we need. Definitely a lot of challenges. Some processes have had to change, and we've had to do some changes to our phone systems and some of our other processes for handling the orders. But yeah, we continue as is. We've had no issues with anybody getting the COVID, and knock on wood that continues. We're slowly coming back up to speed and bringing more and more people back in. We did have to lay off a few people. We've rehired a couple of them already, and we expect to be able to rehire the rest shortly.
Awesome. So yeah, still trucking along. So cool. Thanks for that, Darren.
No worries.
Cool. So we're going to go ahead and dive into some of the technical questions that we have gathered here over the past couple of weeks once we announced this webinar.
crank it up a little bit.
So Ben, this first group of questions is definitely up your alley. So the most common question when we go to trade shows and things like that is usually, what's the latest? So what's new? What's coming out? So Ben, what do we have in the pipeline?
Yeah, sure. So, one of the most exciting things that we have come out is, you may have seen on some of Sam's socials and stuff, is the new Retrotec Reveal. It's the new leak locator fog machine. It has a ton of cool features in here. It has a rechargeable battery on here. So if the battery's fully charged and you have this 30 cc syringe full of fog fluid, you can run this continuously for an hour. It has Bluetooth on it, so you can actually fire this thing remotely from your phone if it's up on an extension pole or inside an isolated, like for doing window testing, things like that. It might be isolated inside the chamber on its own. Has the USB-C, can't really see it there, I don't think, but USB-C charging port, and it's a really cool product, really ergonomic and well designed, and we're expecting this to come out in the fall.
Cool, thanks. Yeah, we were talking earlier, and this is really the first handheld fog machine that's specifically designed for building science and HVAC. So, yeah, definitely excited about that.
Yeah, most definitely. I'm just going to grab this flow box.
Yeah.
And then we also have this kind of two tools in one product here. We have this exhaust flow meter, but if you seal up all four of the range plugs on the back here, then you can also use it as a pressure pan. Use the whole flow mode function in your gauge, and also has a pole mount on here for getting to those hard to reach places, and also still uses the same plugs that we use on all the rest of our fans and everything. So these range plugs are interchangeable between the 5,000, the 300, the 400, and also this flow box now. So it's pretty exciting.
Cool. Yeah, and it doesn't matter which way you put the box on the fan too. It's got 4 pressure pickups on the inside instead of just one, and it's a little bit bigger than competing products also. So that way you can fit it over those light fans that have light fixtures built in. So yeah, that's a cool product.
And then lastly, I think just the we've been working on this wind dampening cloth, this thing that's called the Smart Cloth that should be coming out this summer. Super excited about that. Helps really keep the reference tube, out of the wind, out of the velocity of the fan. No matter who's going to test a building, the location of the reference tubing is always going to be in the same place and everything. So, something that's really excited about, and that's coming out here just in shortly this summer, I bet. So,
cool.
I think that's it for me for now.
Yeah, all that we're allowed to talk about.
Yeah, right.
Cool. The next question we have on here, we just talked about the Bluetooth connectivity that the Reveal is going to have, but a question that we get is, will Bluetooth ever be available for the DM32?
Yeah, most definitely. That is one of the key features that we are working on a new series of digital manometers that'll probably come out sometime next year, and Bluetooth amongst a lot of the other technological innovations that are happening with like better screens and better Wi-Fi capability and things like that, capacitive touch. All those kinds of things will be part of that platform as for sure. So, and it also, like the Reveal 2 also has the new Bluetooth standard, same as what the next version of the manometers will have. So it has that longer range, a little bit longer, just that 30 feet limitation and everything. Super easy to connect to your mobile device and everything for connecting to things like rCloud and Gauge Remote and stuff like that. So super excited about it.
And so what kind of range does that version typically provide?
I really have to go back and look exactly, but I think it's about 800 feet or something like that. It always depends on environment and everything, but I think that's what it is, versus 30, which is the current limitation of your standard Bluetooth from a year or so ago.
Awesome. Cool. So still on the DM32 subject, how is the DM32 manometer different from other HVAC manometers? What sets it apart?
Yeah, I really think that this tool, this platform was really built with building science in mind and the tools that everyone uses and stuff, and kind of starting with the digital pressure sensors inside. They're state-of-the-art 24-bit high resolution, high precision pressure transducers that you're probably not going to find on some of those maybe less expensive products. Then also with the auto zero technology, we have it does it mechanically, so you can auto zero the manometer even if there's pressure being applied from, say if it's still connected to a running fan or there's some wind that's affecting the gauge or whatever, you still have that option of zeroing out the pressure transducers without having to disconnect everything and just do it through software when you first turn it on.
Cool. Yeah, I know a lot of our customers are HVAC contractors. And so when you get into that industry, there's a ton of manometers to choose from. So when looking at, comparing manometers across the board, what are some of the differences that are out there? And, first of all, how does the manometer even read pressure? So what is the internal workings like?
Yeah, sure. So, there's these, they call them Wheatstone bridges. It's like a resistor array that's inside the little tiny pressure transducers that, kind of has like a membrane on it, kind of like, I think of it as like a balloon. It's a membrane of silicon that gets stretched. And as it stretches, it changes the resistance in those resistors. And that's how it reads pressure, really. So that's how it transforms the physical, thing that's happening to a digital form. I don't know if hopefully was that a decent answer, Sam?
Yeah, that was good. I know one thing, there's one of the differences in between some manometers is some have an analog sensor and some have a digital sensor. And I know recently we've made that switch from analog to digital. So what are some of the differences and benefits of that?
Yeah, sure. So, years back, you would get a pressure transducer that would have an analog output, and then you would get your own AD converter and you do your own discrete AD conversions on it. And, I'm sure it worked great. And there used to be like, 8-bit, 12-bit, 16-bit, 18-bit, 24-bit AD converters as it kind of came along. So, the precision, the resolution, as time went on, it just got better and better and better. And then also over that same kind of time frame, then, things got smaller and smaller and smaller. So, now the pressure sensor companies have the ability to take these really very small 24-bit AD converters and stick them right inside the pressure sensor. So you get this all in one package, really. So like, it's always this analog to digital conversion that's happening. So, you could always say an analog sensor, you could always say a digital sensor, it would always be the same, It's an analog device being converted to a digital signal.
Gotcha. Cool. So our next one we have here, so our duct tester is definitely a different type of tool than other residential duct testers that are out there. So why does our duct tester use a different fan type than a blower door or like the TEC duct blaster?
Yeah, sure. So there's I think like there's pros and cons to each, really. Like there's two types, really. There's the axial type fan, and then there's kind of this impeller style fan. And that, the impeller style fan can handle higher back pressures. So you can, and without impacting the flow as much as maybe on an axial fan. And so then, it can handle that static pressure and still keep up with the flow rates versus kind of more of an axial fan where it's a little bit tougher to, keep those higher back pressures while you're maintaining, the same flow rates that you would hope to get, which I know, Colin, you think that's a good explanation, really?
Yeah, that sounds pretty good to me. It's remarkable how much back pressure there is just in a flex duct. So an axial fan in free air, you might have 1500 CFM. When you slap a flex duct on it, you'd be lucky if you get 600. And that back pressure backs up into the flow unit itself. And the more back pressure you get, the more error you get. So if you take an axial fan and you lay it on its back, it flows zero. Because the air is spinning around, it'll still say there's 800 CFM there, which is an extreme example of what happens when you have massive amounts of back pressure. So back pressure is kind of the enemy of flow measurement. And with the type of centrifugal blower that Retrotec is using right now, it isolates the flow unit, which is upstream, from the airflow downstream through the centrifugal blower, and you don't get that upstream, backstream feedback thing. How's that?
Awesome.
Yeah, good.
Yeah, thanks. So Colin, good timing because this next one's for you. So where did the red and yellow come from?
One funny story was when we had our units that were black and white, we turned around and I guess they were cleaning up and they just thought it was a bunch of junk and threw it all out. And then the other thing was people would lose things. So up in attics and whatnot. So we found yellow and red was the color that you would notice. And but we went from red, gray, red, beige, red yellow, which also photographs better than black white. It's too extreme, and it never photographs well. Like mid colors photograph better, and it's kind of McDonald's colors as well. So kind of remind you where to have your breakfast. I think Jerry had the McDonald arches. I got a lot of fun poked at me for coming up with those colors, but I thought, well, look, if we're as successful as McDonald's, I don't mind.
Yeah,
well, you can really tell behind me, right? The product really pops out of this, you know, the trade show booth that we have set up back here or whatever. So colors really stand out. They're kind of that industrial kind of look to them as well, really, you know.
And people like Fluke and companies like that it seems like yellow is the color of industrial instruments. And so we're kind of going along with that too.
It's very interesting, actually, when with the Europeans, having been over in the Netherlands for a year and a half with Retrotec Europe, when we had a prototype that didn't have yellow in it, everybody first question is like, how can that be Retrotec? It doesn't have yellow. So
yeah, the yellow fan, yeah, we can.
Yeah, it's definitely brand recognition is pretty strong with the yellow.
Really had to lean into it once you started. Yeah.
Yeah.
So Joe Madosh just popped up and asked us, so why do both brands of blower door use a red cloth? Anybody know that one?
Yeah, no, Colin must know this one.
Because people that make things out of cloth, red is the color they have in stock. It's like red or black. That's what they have. So it's hard to get any other color. Also, if you go for a light color like yellow, it tends to show dirt a lot better. So that's kind of the two reasons why.
Gotcha.
The other thing was on the red. I think I have this right. Our color thing is red to red, so it's the red tube goes through the red panel.
Mm-hmm. Cool. Thanks. So the next question we have, one of the most common questions is, when are you guys going to make those things lighter? Why are blower doors so heavy? So Ben, I'll throw that one at you.
Yeah, sure. Just making sure my mic's turned on still. But yeah, and I think that the fan itself right now weighs about 34 pounds. And if you kind of break it all up, the biggest, consume or, to the weight is the motor really. So that's probably like 55% of the weight is in the motor. And then, some more of it in the shell and things. So I think as technology kind of continues to improve with material selection and everything like that, that you're probably going to see that probably lighten up over the next, few years or something like that with opportunities that are out there for weight reduction in those material selections and whatever. So, keep your eyes peeled. I mean, the Model 300 that we have has that super lightweight DC motor in there and stuff like that, so there are opportunities to, make a nice lightweight product because, we have to carry these things around here too all the time. Everyone around here is pumped up, got huge biceps from hauling these fans around all the time and stuff. So like,
especially when you do multifamily.
Yeah, exactly. Hauling them up the stairs and everything, so we also feel the pain, so we definitely looking for any opportunity that we can do some, ergonomics and weight reduction and things.
Cool. So I'm going to pop into the question box and see.
Yeah, answer the one about your mustache.
Yeah. I guess why not? It's quarantine, got bored. Wanted to see how long I could go, and it's still here. Thanks, Bill. Yeah. Bill also said loss prevention yellow. So I guess that's what shade of yellow we have.
Point, yeah.
So Paul says, any thoughts on adding this feature? Multi-zone readings are required in Canada for data entry into the Hot 2000 modeling software. I'm not familiar with that. Anybody know that one?
Yeah, he's referring to using one fan to test a two-zone residential. In Hot 2000, you connect a reference to the other zone. Based on what pressure's in the other zone, it can determine or estimate leakage across that shared wall. So it's a way of doing a two-zone test with one fan. We don't have it supported currently, although you can use our equipment to do it in Hot 2000. I don't know if we plan to add it in the future. Actually, that might be a good question for Ben.
And this also
Gotcha.
might be like a really good opportunity to maybe talk about like the new version of Fantastic that's, you know, on the horizon here. Maybe Darren could speak to a little bit. And, you know, we have taken tons of customer feedback and, you know, things that have come up in the field and everything, tried to incorporate in this new version. So.
Yeah, there's been a lot of new work in Fantastic, just really to reskin it, to revamp it, to just make it look a lot more modern, and in the process improve all of the workflows that people are using to make it easier and simpler to see. We're nearing beta stage. We should be in beta stage probably mid to late July, and then release will follow from that. But right now, yeah, the developers are working really hard on it. I think we had a couple screenshots. I don't know if you were going to pull those up, Sam, or was they available, or?
Yeah.
So this is the old version, screenshot from the old version, what it looks like. And then if we move to,
There, we got a couple of these older ones here that show.
yeah, so this is some of the older look and feel. If people are used to using the Fantastic, they'll recognize that. This is one of the new screens, the look and feel. It's a lot more modern. It's using, you know, it's been redesigned with a UI expert. And I'm not going to walk through all the buttons. We don't have too much time to do so, but the charting's been updated. The look and feel's been updated. There's actually been a lot of new movement around the workflow so that we're actually checking from one spot to another and going through. I don't know how much, yeah, I don't want to get into too much detail here,
Sure.
but it is a new look and feel. It's imminent release. Probably looking at, my best guess at this point would be September. Possibly earlier, possibly later, depending on how the testing goes. We do got to go through some live testing with some people in the field before we get to a point where we're going to release it.
Cool. Yeah, and this is the first time we've actually shown what any of this looks like. So if you're on this webinar, you're getting kind of the first little sneak peek of it. So it's definitely, we've been talking about it for a while. It's been in the works for a long time. So yeah, we're definitely excited to get this out there. And I know our large building testers are excited for it too.
Mm-hmm.
Cool. Thanks for that, Darren.
Yeah, no worries. Once we finish, this is for the energy side. Once we finish this, I know it's not maybe the same audience, but the enclosure integrity version of this software will also go through a revamp as well.
Cool. Awesome. So we have one more question here in the box. Edward had a question about doing blower door tests right now for occupied homes during COVID-19. We don't really have any guidelines. It's new for everybody. I mean, that's my best answer. I mean, I'm not saying you can or you can't. I mean, I'm not with the CDC. I'm not an expert, and none of us are health experts. So I don't know if we really have the authority to say whether if it's gonna, you know, cause harm or be safe. So anybody else want to throw their hat in the ring on that one?
And what you said about the CDC and you know, every state has their own authorities and they treat everything different. I think you got to go with wherever your location's at and wherever your state or province or country.
Yeah, Nate Adams just popped into the chat. He and I did a great webinar a while back once this got going on COVID-19 and working with homes. But he says that, you know, flushing air seems to be a benefit. So that's from his perspective there. So yeah, if you haven't seen that webinar, it's on our YouTube channel, so that we really go into the weeds on how this how viruses are affecting us in the home. So that one's definitely out there for you to check out. Cool. So we're going to go back to our list here. Lee, this one's for you. How can I tell if I need to add another fan? Or how can I tell how many fans I need if it's a large building or maybe a really large home?
Okay. Yeah, good question. I'm going to share my screen here. We have a couple of ways to do that. So the first being the number of fans calculator, which you can download from our website under software, there's this category tester tools. And the first option here, the number of fans calculator, click on this, and there's a download button for the Excel file, which is gonna look like this when you open it, excuse me. And it's pretty simple. You just put in, if you want imperial or metric units, what the frequency of the power is. So in North America, it's gonna be 60 Hertz. That just changes the maximum flow it'll tell you the fans can do. And then you're putting in either length, width, and height, volume, or envelope area. And for most purposes, or for most applications, I just recommend doing volume, because you can calculate that pretty easily by doing the square footage multiplied by your height. And based on the volume, it'll give you some output on flow required and how many fans needed. And the second section is the useful one. There's a air changes per hour at 50 Pascal, and it'll show you at 2 air changes per hour how many CFM it's going to require and how many fans it will require. So 2 air changes per hour is a pretty small amount, and I usually recommend just doing this manually because it's almost faster. So as long as you know the maximum flow rate for the 5,000 and the 6,000 or whatever fan you're using, you can figure out if you can test a house. Basically, it's just square footage multiplied by the average height of the conditioned volume, whether it's the eave or the top of the attic or the actual ceiling, and then you multiply that by your air change rate cutoff. So basically, your volume times your air change rate is going to give you your max allowed flow in CFH, and then you can take that and divide it by 60 to get your CFM, and you just compare that to your cutoff. So as an example, 3,000 square feet, 14-foot height, 5 air changes gives you 210,000 cubic feet per hour. And then that 210,000 cubic feet per hour divided by 60 to get your CFM. So in this case, we could definitely test this house with either fan. So it's kind of a quick rundown of that, but this is really handy to know. And you can do the same for other kinds of testing, like duct testing. As long as you know what your cutoff is and what the max flow of the fan is, you can determine the how much flow you'll need.
Yeah, so for blower door, I mean, you really just need to know you need to know all parameters of the building. Really, you got to know whether if it's the volume or just the surface area of all sides. And sometimes for existing it can be tough. Sometimes there's not a target to shoot for. So I think it's always good to create your own. And I know one thing that the HVAC 2.0 guys are doing. They're doing the 1-to-1 ratio of heated square footage with CFM 50 number just to kind of start with a baseline. So, that's one place to start if you're just working with existing. That works pretty well. So yeah, you got to kind of have that target and got to know those building aspects, and then the calculator takes it from there. Cool. Thanks, Lee.
Sure.
So Darren, what's the largest building that's ever been tested? Darren, you're muted.
Sorry.
There we go.
Yeah, the largest building ever tested from our side with our equipment that I know of is a Amazon building in Poland, which was 1.142 million square meter or cubic meters, or about 40 million cubic feet. In square footage, I think that worked out to about 101,500 or so square feet. And that was tested in 2013 with, I believe, I'm trying to remember the number of fans. I think it was 40 fans. We actually have a little video up on our website. You can see the size of the building being tested and the fans going through. And that was tested in conjunction with our Latvian reseller, Andre via Best, and at the time, building doctor of the Netherlands helped out. As far as largest ever, I think that might be it. Sorry, it was 117,600 square feet, as I believe it was. Is that a good enough answer for you there, Sam?
Yeah, we had a question. Was this a new construction test, or was it existing, or did it lead to any actions for remediation?
It was a new construction.
Okay.
And it was an Amazon distribution. So for shipping for Amazon hub in Poland. Yeah.
Gotcha. Cool. The next one we have is, You know, for our residential guys, they are usually used to dealing with one fan. But there are cases where you deal with really large, really leaky houses where one fan just won't cut it. So if you're primarily working residential, you may not be too familiar with multi-fan testing, and it is a bit different. So the one question we have is how do you set up more than one blower door to get a good reading? And I've got a diagram here that I can share to go through that. So if you can see my screen now, basically this is what you don't want to do. I want to start there before we get to the correct way to do it. This is what a lot of people tried. I try to individually control each fan with a manometer. And this causes issues in most cases where the fans end up fighting each other. We want our fans to work together. We want them to run at the same speed at the same time and to achieve the same goal. If we don't do that, yeah, we can have this issue here where, you know, sometimes we might pull one fan, you know, in the opposite direction, and it's just a really inefficient way, and you can really get your numbers off by doing that. So the way we've designed our equipment is to daisy chain the fans together. So if you've ever looked on your blower door fan, there's an in and an out port for a Cat 5. So that's so that you can have a dominant gauge here at the top, and then you can use another Cat 5 cable to daisy chain these fans together. So whichever this gauge is first, this gauge is telling all the other fans what to do. So they're all doing the same thing at the same time. So that way you can crank up all the fans at the same time. There's other brands out there where you have to release them one by one as you keep them covered up with the shower cap cover. But when you hook them up this way, you don't have to do that. You can just crank them all up with the push of a button. And for really big tests, if you're using like more than 4 fans, you can use an Ethernet hub. And so that way you can plug several gauges into one hub and then come into a router and then to your PC. If you look at the Cat 5 cable, the port on the bottom of your DM32, that's where that comes out. So that first gauge is hooked up with that top port, and then all your other gauges are coming out of that bottom port to your Ethernet hub or to your router. And that's how the software is able to tell what's going on. So when you use your fantastic software that we just showed you, we like to have one fan or one gauge per fan, so that way we can see exactly what's going on, make sure everything's cooperating. So it's best to use software like Fantastic. That way you can have full control from one spot. You know that everything's cooperating the way it should. And especially if you're using our Model 6000 fan, the more powerful one, you want one fan per circuit because they will trip a breaker if you don't. So that's something else to keep in mind. So that's a quick and dirty crash course on multi-fan testing. Let's go. I think we have a few more back in our question box here. Someone asked, can I use a Retrotec cloth for 200 or 300 with a Minneapolis duct blaster? Anybody ever tried that?
Yeah, what's the real question?
They want to know if they can use our cloth for the duct tester for their TEC duct blaster.
Yeah, there's like no reason why, you know, you couldn't use the cloths are kind of interchangeable. Really, the only goal with them is really just kind of block the airflow, block the entryway. Yeah. So
I guess the question is,
as long as the fan fits, you know, nice and snugly inside the.
I guess that's the real question: if the fan will fit.
Diameter.
But, yeah.
I see. Yeah.
Yeah.
I don't know.
Yeah,
we never tried that.
Never tried that, but we'd recommend you have one of our fans.
Yeah. They fit perfectly.
But you know, if we can, yeah, it would have to be something we haven't tried it.
Let's see. Someone else asked, why hasn't commercial blower door testing caught on in the U.S.? Yeah, that's a good one. I guess one way to start that off is it is slowly but surely. I know in North Carolina here, we actually finally wrote air barriers into our new construction code. I mean, you don't necessarily have to test, but it is the easiest way to get around it. So it's slowly getting there. But yeah, we are hoping to see more of that. I guess over in Seattle, it's catching on, right?
Yeah, there are pockets which have, right? I mean, obviously, like Seattle was ahead of the curve. I'm in Canada, and Vancouver in British Columbia has recently jumped on board just a year ago. So there are pockets that are happening around the States and around the world. But yeah, it is definitely been a slower, looks like everything is so tough to get things going.
I think we've also made it a lot easier too with the Model 400. You know, it's a lot lighter weight unit to kind of carry around and stuff versus kind of the traditional old school big ones on a dolly and stuff like that. So, you know, hopefully with the ease of use of the equipment and everything, that will start to really kind of take hold more.
Sure. Yeah, and I know it's catching on in New York too. I know there's a lot of commercial tests there, and I know there's a committee and a big push to get California on board too. So hopefully that'll pop on soon. So
one of the few times California's not on the leading edge.
Yeah, exactly. So baby steps. I mean, it's happening. It's just really, really slow.
I just wanted to make a quick comment about that. I understand you're talking about commercial duct testing, right?
No, we're
not just commercial
blower
testing.
door.
Like building?
Yeah,
Yes.
commercial building testing, large building.
Okay. Well, my comment on that would be, I think it was 5 years ago, U.S. Army Corps of Engineers who work with us to, I guess, initiate the standard, documented, I think, around 500 tests that had been done, and that was 5 years ago. So there are a lot of tests being done, but they're done by kind of large specialized engineering firms, which are kind of different from your average run-of-the-mill blower door guy.
Cool. Thanks. Next question we have on the list is, we get this one a lot, is, you know, the difference between multi-point and single point blower door testing. So Lee, what makes a multi-point test more accurate? Lee, you're muted.
Thanks.
Yeah.
All right. Yeah, basically it's all about reducing wind impact and other slight variables that can change your flow numbers. With a single point test, you take a single reading, and if that flow is offset for any reason, that's going to change your results by a pretty large degree. With multiple point testing, you're taking a series of points, and you're, in theory, averaging out any of those small variances, and you're figuring out what the flow is and what or how much it increases per Pascal of test pressure increase. So your end results are going to be a lot more accurate just because it reduces that potential error.
Well, and we had another question too, Lee. Maybe describe what a multi-point test is. Like, how do you conduct one of those?
Okay. Yeah, it's basically similar to a single point test, but you're starting at a higher pressure and working down in intervals to take multiple points. So instead of a single flow reading at 50 Pascal, we would take a flow reading at 75, 55, or, you know, you can do equally spaced intervals, and our software does this automatically. It tells you what pressures it's going to record. And then all those flow rates are plots on a graph, and it's used to determine the slope of leakage, how much it would increase per Pascal of test pressure increase. And then your results are basically pulled from that data. So instead of taking a single point, you're taking a series of points and then using that data to get an average result. And then typically you would do it in both directions, pressurization and depressurization.
Cool. Yeah, Nate's asking some more questions here, so I'm going to knock these out. So essentially what we're doing when we do a single point test, we're assuming what the slope of the line is for our flow, and it's, you know, we assume 0.65 if you look at the flow equation. And so when we do a multi-point test, we take that assumption out. We actually determine what that is by taking it at different variables there. And so he asked about rCloud, like what setting do you use? So if you go into rCloud and you click on blower door, you can choose a single or multi-point test. So you just go ahead and choose multi-point. And one thing to point out is that since you're starting out, rCloud, what it does is it starts at 60 Pascals and then goes in intervals of 10 all the way down to 0. So at some point, and maybe twice, you're going to have to reduce your range on your blower door. So you'll pause the test, you'll reduce your range to wherever you need to go, you'll make that match in the app, and then you hit resume and the test will continue. So it takes about 8 minutes to go through and do a multi-point test in rCloud. But just because you're not making assumptions about the slope for that equation, it gives you a more accurate reading. Cool. So we're going to move on again. A question we get a lot is about testing ventilation. A lot of the times the question is like, what's the best way to test ventilation? So it's definitely like an answer that starts off like a lot of these do is like, well, it depends. What kind of ventilation, what kind of tool are you using? So if we're talking about whole house ventilation, you know, and if you know, tools aren't an issue, I mean, we like to recommend the ASIN flow hood just because it's the really the only device that has a calibrated fan and manometer built into it. If you use a flow hood that has more of a passive design, it's relying on sensors. And so sometimes you can take your reading, you can turn the flow hood at a different angle and put it back on and then get a different reading that way. So that's with using flow hoods. You can use, you know, hot wire anemometers, vane anemometers too. Vane anemometers, of course, it just depends on how many readings you take and average them together. Hot wire anemometer seems to work pretty well for some cases, especially if you have that one ventilation duct that's hard to get to. I just don't like using them on flex ducts. If I have to do that, I try to avoid poking holes into those because it's basically like a trash bag. It's just going to keep ripping. But yeah, if you can really get to that inlet, or I guess that intake for ventilation, if you can use a calibrated powered flow hood, that's really the best way to go. And you can use those for kitchen exhaust too, because you can actually pop that hood off of that, and it's actually pretty small, and you can kind of create your own to use for kitchen exhaust. Because that's the next question up here is about kitchen exhaust, because there's not really a great tool out there right now to measure, you know, vent hoods, because vent hoods are, you know, come in all different shapes and sizes. So it would have to be something adjustable and airtight, which would be pretty tough to make. So you can use something like that, or like our flow box that Ben showed earlier. And whether if you're using duct mask tape, or if you create, you know, your own custom size box for that hood out of, you know, rigid foam or something like that, that's possible too. Kitchen exhaust can be a little tricky. I had one tester that I was working with a few weeks ago that it was a house on a golf course that had this ridiculous commercial kitchen exhaust in it that actually put about 10 pascals negative, put the house about 10 pascals negative when it would run. So you could actually pressure match that with the blower door and get an idea of what that flow was with that. So, and you can do that with a duct tester too in some cases. So there's different ways to do it. Measuring kitchen exhaust isn't always easy, but
it just kind of depends on your requirement too, really, right? Like the ASIN flow finder is going to give you like plus or minus 3% accuracy versus like the flow box or an exhaust fan meter is like plus or minus 10%, or some of those passive hoods that are, you know, greater than 20% accuracy at times or whatever. So it kind of depends on your needs as well.
Yeah, absolutely.
Sorry, the one other way to do that would be with the duct tester and the flow hood. So you can actually make a powered flow hood by using an accessory on, in addition to our 300 series duct tester.
Yeah, that's like that's basically our large 24 by 24 inch pressure pan with a hole that the end of the flex can tie into. So yeah, so you can make a flow hood that way. Cool. Yeah, thanks, Lee. Okay, so next question, Lee, this one's for you. When we do blower door tests, one thing that we try to control for is wind. And you know, days like today in Eastern North Carolina, it's been windy all week. So doing blower door tests during this time is pretty tough. So what's the best way to manage that, Lee?
Okay. Yeah, it's a lot of times it's hard to completely negate the effects of wind, but the two most common things are just increase your time averaging interval or take more points if you're doing an auto test. And then you can also split your reference tube. So you have your red reference line, and typically you're set up inside, and you run that out through your door panel. You can put a T on the end of that and run it to opposite sides of the building, and that will give you a pressure average across the building. A lot of times that helps out quite a bit. Or things like try to set up in a different door, maybe on the leeward side away from the wind. And yeah, I mean, that's primarily it. You can also use semi-auto to overwrite points if they're particularly bad. So if you're using Fantastic, you'll see on the bottom of each point, it'll say the error percentage. And you can pick out points that are bad and just overwrite them, wait for a break in the wind, or try to change your reference tube location to get a better result. And between all those things, you should be able to get some decent data most of the time.
Cool. Yeah, thanks for that. And that's where that smart cloth comes in too, that we're going to be rolling out this year that Ben was talking about earlier. So essentially what that's going to be is your outdoor reference tube that's actually going to be stitched into the cloth that branches off in a couple of different locations to help dampen the wind that way. So the testing that we've done so far, Ben, what were the wind conditions that day when you guys did the testing on that?
Yeah, I wish I would have had the graph here to share with everyone or whatever, but it was gusting at 35 plus miles an hour or whatever, and you could see a significant reduction in the it's kind of more mechanical wind dampening really. So with the tubing sewn into the cloth and everything, with the two references inside there teed off and everything, so it just kind of like the cloth acts as like the wind dampener that somebody might use when they're like trying to put reference tube into soda cans and socks and hats and all sorts of other stuff, whatever is trying to cut down on the effects of wind and everything. And I think you just really want to monitor your, like, I can't remember exactly, but like your bias pressure readings, Lee. When do you know when it's too windy to actually do the test?
Well, it depends on what standard you're testing to, but typically 5 Pascal and over could indicate a problem. It's kind of a good rule of thumb. Yeah, you'll record data and you'll see those bias pressures are high, especially if it's fluctuating. You may get some that are a lot higher than others, and it may just be a matter of changing intervals or waiting for that to die down a bit.
So I think that's why it's like kind of important to use the software like rCloud and Fantastic when doing your testing, because a lot of these constraints and alerts and pop-ups like automatically pop up and alert the user while they're doing the test that, hey, these conditions are kind of outside the ideal world or whatever. So
yeah, great point. The software will usually tell you.
Yeah, I did a blower door test with a HERS rater earlier this year on a really windy day, and we were doing a multi-point test, and we could not get that last reading at 10 pascals. The software would time it out. So we had to take it off, put it on the leeward side of the house, put a T on it, and put it in the manometer bag, and we're finally able to run it again and get that. So hopefully that smart cloth will help remove that issue.
Yeah.
And that's a great point about the 10 Pascal point. The lower your test pressure is, the more the wind is going to affect your readings. So a lot of times you can actually bump up your first reading to a higher pressure, so you end at a higher pressure. And then the percentage of how much that wind is acting on your test pressure is a lower amount. So that could be a good tactic as well.
Cool. Excellent. I'm popping open the question box again here. Jesse Kinsley asks, does Retrotec offer any equipment for pressurizing multiple adjoining units that do not communicate air? For example, walk-up apartments, jumper duct. I think I get what he's asking. So basically trying to test multiple units at one time. Lee, has that ever come across your desk?
Yeah, we don't have anything that Jesse is asking for, like a jumper duct or something to connect multiple zones together. Typically, you would do that with multiple fans or pressurize a hallway and open doors if there's a zone you can pressurize that's connected to everything else you're testing. Yeah, I don't know of any product that would be like a jumper duct. Typically, you just set up fans in the doors that you need to test, or use that common hallway method. For a lot of these, if you're testing like walk-up units or apartments, and you do have to neutralize, a lot of times you can get away with 3 fans, one on either side of what you're testing to neutralize, and then one in the middle for actually doing the test. And you can just move those down as you go along. But yeah, I don't know of a single fan method to do that.
Yeah, that's my experience too. I did a test with a group where it was a 17 fan test on a dormitory, and there was one standalone apartment off to the side that we had to include, and so we just ran its own fan over there and just ran it with the rest. So yeah, so I guess you're just gonna have a fan per unit, or just test the units one by one and then add them up. Let's see. Is there a way to do a blower door test on a small apartment with a duct tester fan? Yes, there is. We make a canvas that has a small hole for that fan to fit into. So as long as it's within the reach of that fan, which is about 800 CFM, there's no reason why you can't do that. When you go into your DM32, you'll select the model 300 when you use your duct tester as a blower door fan. That's what you select. So yep, people do that all the time, especially for passive house and small apartments. Joe Medosh popped in. Yeah, there's also a window frame for the duct tester too, so you can set it up in a window. That way you don't have to use a doorway if you don't want to, or if you want to include the leakage of the doorways in there, there's an option for that. Cool. So we'll keep trucking. Darren, why is the Tiny S so expensive? That's the one we get a lot.
Yeah, well, unfortunately, we don't have control on the pricing of the Tiny S. You'll note that if you try to buy the Tiny S through, okay, first of all, the Tiny S is built in Germany by a company called Look Solutions. It's not built for our market. It's built for the entertainment industry, for music videos, concerts, the movie industry. That's what this fog machine was intended for when it was built. And if you tried to buy this Tiny S through Look Solutions USA, it's $1,440. So we've actually cut the price down to the bare minimum. We don't make much on it. We're just reselling it. So as far as why it costs so much to build it, that would be a question for Look Solution Germany, but you know, it is what it is. We don't like the price either, and we've obviously heard from many of you that it's quite expensive. And that's why at the beginning of this, you saw a product that Ben showed, the Reveal, which there you are. There, he's been showing it again. This product is a result of the fact that the Tiny S is very expensive, and we thought we could go ahead and produce something that's a little more specifically tailored for this industry and do it at a cheaper cost. So we're hoping to come in $500, $550. We're not sure the pricing yet. We're still sourcing out parts, but that's the ballpark. So we're looking to almost half the price. And we actually think this tool is going to be better than the Tiny S. We expect to have a very solid product that is built specifically for this industry, mountable on an extension pole, fired remotely by Bluetooth, a lot of things that we're hoping and be just as effective and just as durable as the Tiny S currently is. We know it's a good product. Everybody's happy with the Tiny S. We've been selling a ton of them, but the price is high, and we can't control that. We're just a reseller. We have very minimal markup. That's the best answer I can give you.
Right on. Yeah. Thanks, Darren. Ben, this next one's for you. How much does fan and gauge calibration really matter? And how do these tools fall out of calibration?
Sure. You know, I think calibration is always really important. You know, that's why they have NIST traceability out there. You know, all these accreditation bodies to make sure that your laboratories are adhering to, you know, all the regulations and maintenance of your reference devices and everything, you know, so that way that, you know, no matter what kind of tool you're using, whether it's a caliper, you know, that you're measuring pipe with, or a fan that you're measuring airflow with, whatever, that the numbers that you're getting off of that device are, you know, are true and accurate. You don't really have a sense for that if you don't have calibration. So I think that's kind of why it's most important, just to make sure that the tool you're using to get the numbers is real. And that, what was the second part of the question? It was about, how does it fall out of calibration? It, you know, typically like a fan, it's probably not, unless maybe like you maybe perhaps dropped it, fell over, fell out of a doorway while you were testing or something like that. And then the flow signal sensor, the nacelle in the back, kind of maybe it got moved a little bit from where it was when it was originally calibrated. That's probably the most impactful thing, or maybe some clogged tubing for the flow sensors and everything. That could also have an impact. Same with the pressure sensors in your gauge. They could be impacted by, you know, if somebody tried to blow them out with, you know, high pressure compressed air or something like that, they could damage the diaphragms in there. So calibration, just if you go through and do that on a kind of an annual basis or whatever, you're just checking to make sure that, you know, your equipment isn't damaged in one of those ways.
Thanks, Ben.
Yeah.
Dan Wildenhouse sent us a question in. It says, in our experience with multifamily, if you have a builder committed to using resilient channel behind drywall installation, how do you recommend air sealing the party walls? And yeah, I have some experience with this. Resilient channel is one of the options that you can use to make the 1 hour firewall assembly in party walls between two apartment units. And the issue with it is it creates an air pathway behind that wall that can connect to other units either above or below. And so if you put your ceiling up first and you try to butt it all the way over to the top plate, you can't, because there's about a 1/2 inch gap because of that metal strip from the resilient channel. So I've seen contractors do a couple of things. One is add in a strip of fire block foam and then try to strip it away if it gets in the way of putting the rest of the wall assembly up. But probably the most tedious but effective way to block that airflow is using strips of drywall to go in and block that gap and then seal it up with the red or the black fire caulk. And whenever I can, if I can air seal with caulk over spray foam, I like to do it because I think it gets a better seal. With spray foam, you're just kind of shooting it in there and hoping for the best. With caulk, you're actually applying it with your finger or with a tool to really get it into that crack. So, so for those types of units with resilient channel, that's how I've seen them get really tight numbers, is going with those strips of drywall and the caulk. And then he sent us another question. If you could use a door fan test to help a builder see the issues, would you pair it with infrared, smoke, or request a mock-up or anything else?
Is it all of the above?
Yes.
So yeah, they're all good. Sometimes, if you don't have a good delta T between inside and outside, thermal's not going to tell you much. And that's where the smoke really comes in handy. It's another way to make those air pathways visible. And for mock-ups, if it's for large commercial or multifamily, it's very common that they're going to build a mock-up to make sure that it's going to pass rain penetration tests and things like that. So if it's going to be a window or door assembly that's going to be used throughout the building, sure, yeah, do a mock-up and let that be the guinea pig before you throw it all together. Colin, Lee, any other input on anything like that?
No, I think that was a great answer. It's really, whatever you have at your disposal. Everything definitely has pros and cons. Smoke is great to have just all around.
Cool. So Larry from Florida asked us about foam attics, insulating the roof deck. At that point, do we include that in our blower door test or do we not? My answer is yes, you do. At that point, you have moved the air barrier from the ceiling to the roof deck. And so now you have to include that. So it's important to measure out the volume of that space and include that to get your ACH 50. One tool that I like to use if I'm working with existing homes like that and I don't have plans, the Bosch laser distance measurer with Bluetooth on it, their app is really cool. You can actually draw things out as you go. So using a laser distance measurer cuts time in half for sure. So that's my answer to that. And if you're a HERS rater and you're trying to meet ResNet 380, that's basically what it says. You've moved the air barrier, so you have to include that volume. Another question from the guys at Airtight in Australia. Are you guys looking into being able to select a specific test to be printed in Fantastic? Printing the average is not always needed, but it would save a lot of time with multi-test jobs.
I might try and take this one.
Okay.
So I think he's meaning the different sets that are created in the test, not necessarily a different test, because
Okay.
Obviously every test can be printed in separately, but we do run multiple sets of data, pressurized, depressurized, for instance, and then we do an averaging and we print that data. One of the things that I have talked with Jeanette, who's working on the Fantastic reskin, the new version that's coming out, is a much a finer control of the individual sets and the data. So this is something if I'm guessing what he's asking, because what he's asking I'm not 100% clear on, but if what he's asking is the ability to print the individual sets, that should be available in the new version of Fantastic. And I would recommend maybe he email Lee and he'll forward that. Maybe Lee can
just support at retrotec.com. Yeah.
Support at retrotec.com, and we can really make sure that we're answering the question that's actually being asked here.
And you can customize the reports in Fantastic Pro too if you wanted to adjust the template or something like that in there. I think so.
Mm-hmm.
Darren, I think that your interpretation of that question was right. And I actually get this one somewhat frequently. If you're testing multiple spaces that have the same dimensions in the same main building, you have to recreate a test file a lot of times in a row. So you can actually just make one, put in your data, and then copy it to your desktop. And then every time you're doing a new unit, make a copy of that file. So that way when you open it up, it already has your fan and the info in there, and you can just jump right to testing. That's kind of the workaround for the time being.
And actually, like the new version of Fantastic, it's kind of project or building based now, so you can go back and enter in the parameters for the building, and then it maintains them, and you can do multiple tests on that same building without having to go back and re-enter the data. So maybe that's another way of kind of getting around that as well.
Cool.
Good question.
So another question on here, Colin. I'm gonna hand this one over to you. This is about large building testing, and whenever we run our interior reference hoses up to other floors from the gauge, how long of a run of tubing can we use, and at what point do we have to come up with another game plan?
I don't think there's any limit to how long you can go. There's no air that actually flows through these tubes, so as long as the tube doesn't have sun on it, so the air in the tube is the same as the air in the building, it doesn't really matter how far you run it. So there's no real limit there. What does often happen is you get pressures across floors. So when you run it across floors, things start to change, but there's no real limit. There's, since you got me on here, there's a couple of other points I wanted to make. One was when we were talking about wind and repeatability of tests. I found that by far the best way to get repeatable tests is to test in both directions. I realized that, that a lot of standards don't require that, although they all recommend it. So if you did one thing that would make your test repeatable, it'd be testing in both ways, which really increases the repeatability by maybe a factor of 4 or 5. It also gets rid of massive problems with stack, wind, just about everything. Zeroing, bias pressure, space lines, all that stuff is an important thing. There was another question also about pressure zones. So it's possible with the old version of Fantastic, probably the new one as well, that you can run different zones. You don't necessarily have to have a fan in that zone to run it in the software. You can just set it as a neutral fan or a zero fan or something. So you could actually run that and record what's happening in another zone, even though you don't have a fan that is associated with that particular gauge, but it would require another gauge channel. So does that answer that question?
Yeah, thanks, Colin.
Real quick, the one thing I wanted to add on to that is with running the interior tubes or any tube in general, the longer the tube, you are going to have more of a delay for that pressure to reach the sensor. So if you have two very different lengths of tube, just keep that in mind, that the shorter tube will read pressure faster than that longer one.
Great, yeah, thanks. That's a great point. Cool. So we're running just past the hour here. So I think we're safe to go ahead and wrap things up. Of course, if there's questions that any of you have, feel free to reach out to us. My email is sam@retrotec.com. You can reach support@retrotec.com as well. Any last remarks, Ben, Darren?
Just thanks everyone for joining us today. Hopefully,
appreciate it.
Hopefully we got to your question.
Yeah.
Thank you.
Awesome. Yeah, thanks everybody for joining, and we hope this was helpful. Everybody, stay safe, and thanks again.
See ya.
Bye.
See ya.
Nice, Ben.